Hello, everybody. This is Brian Smith with 321 Gang, and you're joining us for our technical podcast, Change the Conversation, where we talk with experts about systems and software engineering, processes, practices, tools, things of that nature. And today we are really pleased to have back Amit Talvar. How are you doing today, Amit?
Good. How about yourself, Brian?
Very well, very well. So this is now, episode 4 of our A-Spice series. And I'm going to use my cheat sheet here and say, let's see, episode 1 was a general conversation about what is A-Spice and why is it important. Episode 2, bidirectional traceability. Episode 3, allocating requirements to architecture, and today we are going to talk about software and systems qualification testing. So, Amit, remind us what part of IBM you're in.
Perfect. Thanks, Brian. Yeah, I'm part of the Watson IoT division, working for industrial clients in North America.
Mm-hmm.
Part of our continuous engineering solutions.
Okay.
I'm part of the field technical sales team. I'm a solution architect. I help customers primarily in automotive, but other industries like medical devices, aerospace and defense, companies that develop embedded software and how they actually meet compliance with different industry standards.
Okay. Very good. Yeah. So let's see. Just to paint the picture real quick before we jump into the tooling here, which, by the way, for people who have been in this industry for a little while, right? The tools here are some kind of combination of legacy rational software tools and telelogic tools and those sorts of things, right? I just sort of want to throw that out there because me personally, I sometimes with the name changes that come about in large companies, I think sometimes it gets lost what tools we're talking about. So it's I think the original name was Rational Continuous Lifecycle Management. Is that what it's? Collaborative Lifecycle Management, right?
Yeah.
And Rhapsody from Telelogic and stuff like that. So and how these tools work together to help meet the requirements of A-Spice is really what we're doing today. So let's see. So we did bidirectional traceability. We talked about how requirements are in a sense the hub of the wheel of these processes. And if you can link requirements bidirectionally to models, to other requirements, to other dependencies, and are able to do analyses of how if you make a change to one, what it impacts on the other end, etc. That's really powerful.
Exactly.
And I think what you're going to show us today is that exists as well, that bidirectional traceability and those links between elements to tests, right? To validation, verification, and testing. So paint a picture for us.
Yeah. So we talked about our continuous engineering platform, right? We covered areas around requirements management. We covered areas around, that bidirectional traceability between our test management solutions, our Rhapsody solution around the architecture and designing the systems.
That's the model-based systems engineering piece, right?
Exactly. Yeah. So what we're going to focus on today is really the right side of the V, right? And any embedded system development, regardless of what industry you're in, everyone knows what the V model. And on the right side of the V, it's really having the ability of having requirements-driven testing, or that the idea of shifting left, which means we're going to test early, we're going to test often. As we're writing the requirements, we're actually writing the tests that are actually going to test those requirements and verify and validate them. Mm-hmm. And we're going to show how that can be enabled by our platform, where we have that tight integration between requirements and tests, so we can have that established bidirectional traceability. We're going to show things around how we can actually, take a look at our requirements that we want to align to our tests, our plans for what we're going to test, generate test case shells, that can then be assigned to other engineers to actually go and develop as requirements are being developed. And we can do that at different phases, whether it's a unit testing phase for software requirements, right, to integration phases, right, every single phase as you go up the right side of the view. And what that really does is it shows that tight coupling, right? There's transparencies available between the requirement engineers and systems engineers and the validation engineers, right? So they can understand they're working in parallel, that they're going to write the requirements in a way that actually can be tested, right? And the test case is actually going to be written in mind of knowing what the requirements are.
Got it.
And both sides have that ability to look at and see, they have that visibility into if something changes, that they're notified. And they're notified immediately and they can take action.
All right.
So those are some of the things that we'll cover today.
Okay, excellent. Should we jump right into it then?
Yeah, we can do that.
Okay, Amit, so what are we looking at here? As we've talked about, requirements are maybe the hub of what we talk about with ASPICE and with a lot of these processes. So here we are again talking about requirements and testing.
Yeah,
so
exactly.
How does this work?
There's lots of benefits for the idea of having requirements-driven testing. What does that actually mean? It means that your testing teams can easily view and test requirements, and they're actually developing the test cases at the same time as the requirements are actually being developed. And the reason that you want to do this is if you are developing your requirements in mind that we need to be able to test them, your requirements are actually going to be written better, and they're going to have, it's going to be a easier job or less risk of having to rework or redo tests or rewrite requirements because they're written correctly in a way that maybe a tester can't test them. There are times where defects are found, and usually the defect is found during a test, and sometimes it's because the requirement was written incorrectly. So if we're having that in mind, where there's that transparency between the systems engineers that are writing the requirements and the validation engineers that are writing these test cases, we kind of minimize that risk. And we have that. Yeah, go ahead.
Yeah, real quick. So this collaboration between business analysts or people who are writing requirements, stories if it's agile, and the folks on the test side. I mean, often those two communities traditionally haven't worked together. So are you saying? Yeah, are you saying that you're going to throw them all in the same room now and have them collaboratively work together on building requirements in a way, or is it more that when they start, they take the requirements and need to start building something, and as they iterate on what they're going to work on, they build the test? Like, how does that?
Exactly. Well, yeah. So it works in that latter case, right?
I see.
As the requirements are being developed, right, we've establishing bidirectional traceability to a test case shell where the test engineer, the validation engineer, is actually developing the test case. Those two artifacts are now linked together, right? So as requirements get updated and they're in draft mode and they're being reviewed, the tester's seeing those things and he's got visibility into it. And at the same time, the tester is developing his test case, the requirements engineer has visibility into it. And so that's fostering that type of collaboration.
I see. So you're breaking down the barriers here.
Exactly. I mean, traditionally what we've seen in the past is requirements get written, they get thrown over the wall to the test engineer, and the test engineers have to go through and write the test cases. Well, let's remove that wall. Let's work. If we're working in an agile way, we're working together on these things, and we're doing these things iteratively, right? And we're refining them in each iteration. So.
Right. All right. Very good.
And so our continuous engineering platform really enables this type of requirements-driven testing, is because we're able to use that power of OSLC that we've talked about in the past, which is an open standard. It stands for Open Services for Lifecycle Collaboration. It's the
link. It's like a data link, right?
Yeah. It's a standard of how lifecycle collaboration tools will talk to each other. And what we've seen here is this type of visibility is if I'm looking at the requirements, I have insight into what's going on from a testing perspective. I have my requirements. I can see that they're validated by a specific test case. If I hover my mouse over it, I see a quick look into what the test case is. I can see things like, I can even see that this test case last time it actually ran and that it failed. So these are these quick indications of what's going on in the test, right? Some of these could be, the test cases themselves could still be in draft mode.
Sure.
Right? Right? As we're still drafting the requirements, we're drafting those test cases, and we're working collaboratively on it. And OSLC gives us that power.
So real quick, this is actually the screenshot of the requirements management tool that has a link to the test cases that are associated with it.
Exactly.
Okay.
And we'll show some of this in the demonstration.
Of course.
So here we are again. We said the hub and requirements. We're looking at our requirements project. This is our adaptive cruise control subsystem requirement specification. We've covered kind of this in the past. We have different views available. The things that I want to point out today is we've actually aligned this specification and the requirements in it to a test plan in Rational Quality Management. And what is a test plan? A test plan is a grouping of tests that we're going to associate for an iteration that we're going to plan out what we're going to test.
So a test plan is aligned with an iteration. I didn't know that. Okay, that's good.
Yeah, it can be aligned with an iteration. It could be aligned with a set of system tests. It could be integration tests. It could be unit tests. Test plans can have a master test plan. So we could have master test plan with separate child test plans. So maybe your master test plan is testing a specific feature across these iterations, vice versa.
It can be grouped in a lot of ways.
Yeah. If we look at the test plan, if we look at the artifacts of the different test entities, we have the planning capabilities with test plans. Those test plans consist of test cases. Test cases are, what we're actually going to, it's like the procedure of what we're going to test. The case in itself might be a manual test, so there might be steps that might need to follow in a manual way. Somebody has to actually go through and do something. This could be automated tests. So if you're utilizing some hill machines, or if you have like a test bench where you do some automated testing that you do, right? The Rational Quality Manager has the ability to execute either one of those. And those are done what we call by test script. So every test case will have a test script, whether it be a manual one or an automated.
Okay.
Test cases can also be grouped together if you need to run them in a specific set like an order. Like I might have 5 test cases and I need to write it in order. Those we can group into what we call our test suites. And test suites, test cases, those all are associated with a test plan because we're going to run those test suites or those test cases based on some planning activity that we have.
All right.
Right. So if we look at this test plan, some of the things I'm going to point out, we can configure our test plans. We have multiple different sections that we can have. We can reduce these. We can decide how we want to configure what we want in the test plan. We can put things like what are our objectives. Things I want to point out is we can manage what our test environments are, whether multiple different test machines, test benches. If you're looking at different vehicle tests, right, you can manage those type of environments and schedule on those. The most important thing, though, is we can look at the idea of requirements-driven testing is we can associate those requirements to this test plan.
Right. This is the bidirectional traceability again,
This is that bidirectional traceability where we've aligned a group of requirements to this test plan. And the value of having that is we can do things like automate and generate test stubs, right, these test case stubs. So I just did a reconciliation, and what that does is it looks at all the requirements that doesn't have any test cases, or if it does, that don't have any test coverage, or not, that might have test cases that are actually not part of this test plan. We've aligned this test plan to cover these requirements. There's a test case created, and what we're looking at, but it's not actually part of this test plan. So one of these things that we can do with this is generate those test case stubs. And I can just select them and say, you know what, I'm going to generate these test cases. And what it's going through is it's going through and generating a new test case for every one of those requirements that didn't have any test coverage. It's actually created the bidirectional traceability link to each one of those requirements, and now it's added those test cases to this test plan. What it'll also do is look at were there any requirements removed or deleted, letting us know that, hey, the requirement is no longer there. You have a test case that will satisfy that requirement. You can probably remove it.
Just in case. All right.
So now I can look at
let's look at
my
that.
test cases that are now associated with this test plan. Right? I can look at all of them. I can see that these are in draft state. Those test cases can have their own workflow. They can be under draft. They can have a review and approval, right? And then once they're approved, you can set up permissions and roles in here that you can only run tests that are approved. And it's a library. So we can reutilize these test cases. So maybe a test case is used for the system test, but maybe there's an integration test plan also where we want to do integration and we're going to reuse the same exact test plan.
So when it automatically creates a test plan for a requirement, it is the idea there, you call it a stub. So somebody then has to go in and define what that test really is, right?
Exactly.
I think the idea is just that there's now one created and you can't move on until it's created and then passes and gets approved.
Exactly. Now if you put in restrictions saying that you can only run tests that have been in an approved state, anything that gets created, it's in draft, right? Okay. You can assign an owner to it, so we can assign this to our test engineers or our validation engineers. Say it's your responsibility to now go work and develop this test case. We can look at that test case in itself. And again, it is a shell. We have different configurations. Maybe we are sections that we can configure on this test case in itself. Maybe you have some risk assessment that you need to fill in. You have some pre or post conditions. You can look at the test case design. And this is an easy way to add. If this is a manual step, I can just create some a quick way to create those test steps, right? So let's turn ignition on.
Hit the gas. Put it in gear.
Stop
right.
Right.
Stop vehicle, right?
And then I can automatically from that test case design, I can create my test script. We'll call this vehicle obstruction.
Now this example, is based upon the premise that you've already written some requirements and they need tests to be associated with them. So ideally this happens, like you said earlier, at the same time or almost at the same time. But this obviously speaks to the fact that in some cases, and maybe in many cases, somebody gets a book of requirements or a subset of requirements and then has to create tests associated with them, right?
Exactly. Or maybe they already have tests associated to them. So that's one thing we can do. So if we look at the test plan in itself, we can actually go through and say, you know what, I can add test cases to this test plan and then establish a link between those test cases and those requirements so that they're going to satisfy.
So you can go the other way.
Yeah, exactly. If we look at this actual, we created this test script off of this test case design. Now we can actually see what this test script is. And really, it's just taking that step by step, right? Here's the expected results. We can go through, if we want, we can go ahead and run this.
Oh, look at that.
All right, we can do things like record a manual script.
Okay.
We go back, we can actually go through and let's get back to the test case. And let's actually go through and let's actually run it. So I'm going to go through and run this. And it's going to take me through those steps, right? So I'm going to say, yep, I turn the ignition on, yep, that one passed. Hit the gas, yep, that one passed. I want to try to stop the vehicle. You know what? That failed.
Failed, which is bad because the obstruction response is supposed to probably stop the vehicle, right?
So if we go
So
through and we finish out this test case, we ran it, we show the result, we can see that this thing failed.
Mm-hmm.
We can add, screenshots to this if we want, add attachments. And we can go say, you know what, let's create a defect off of this one. We know this thing failed. I can go through and with the push of a button, create a new defect. File it against, this autonomous braking, because this was supposed to stop on its own.
Mm-hmm.
And now
go
I
ahead.
created this defect.
So correct me if I'm wrong, but I mean these are best practices for validation, verification, and quality testing, quality management, right? So our series is about ASPICE, but really these are best practices that could be used outside of ASPICE, right?
Regardless of what industry you're in, these are best practices. If you look at verification, validation, testing, regardless of what industry you're in, there's a lot of similarities between them.
And so
ASPICE relation with ASPICE is making sure that there's established bidirectional traceability, which other industry standards have that same requirement.
And so you could demonstrate that on paper, but it would be far less productive, right? So
exactly.
what we're talking about here is automating it, breaking down communication barriers, and improving productivity.
Yeah, and I look at this. This is what I call the money ball when I talk to our clients. I just created this defect. Let me actually go look at this defect.
All right.
I go look at this defect, and I can see when that defect gets assigned to a software engineer, if I'm the software engineer that gets this defect now, I can look at this defect. I know what test plan it was ran in. I know the test case that's associated to it. I know the requirement that's associated to it. So I don't have to go looking for this information. It's at my fingertips. So if I know it's not an issue with my code and I go back and look, you know what? The requirement was written incorrectly. Right? The way that the tester wrote the test case and how he was testing is not what was written in the requirement, how the requirement was written. There's not an issue with my code. Right? Let's go fix the requirement, or let's go fix that test. That information's right available to you. Instead of having to go scramble, water cooler conversations, checking things through email, right? It's right at my fingertips.
Yeah, that's huge. I can imagine that streamlines the process for sure. You mentioned something about this defect gets assigned to, for example, an engineer. Who does that assigning? I assume that there must be some delegation built into the tool, because as a tester, I might not know which engineer ought to work to resolve this problem.
It's a process thing, exactly. Usually what I see with my clients and the best practice is defects get assigned to some type of backlog where they hadn't been. You might have a team that goes through and triages them, right?
And then assigns it.
Figures out severity. Is it a blocking defect? Is it something that we need to fix for this iteration because we have to get this code back out? And then it can be prioritized, just like you do your traditional backlog grooming. You prioritize it and assign it to engineers.
Right. That makes sense to me, yeah. All right.
So
that's super
we
cool.
We talked about bidirectional traceability. We saw that from one of the things that we saw that visibility in from a testing engineer, but from a validation engineer perspective, I can also look at these test cases and see that coverage. I can look at a traceability. I can see all my test cases, all the requirements that are testing them. So I have that visibility into it from that area also. We have that ability to mark things as suspect. So if I mark this as valid and I go back and change that requirement, I'll get notification that requirement has changed. I'll see that thing marked as suspect. And that's when I know, hey, there's been some change. I need to validate whether or not is my test case still accurate based on the requirement as it is today.
And if so, will it still pass?
Exactly. Do I need to rerun? My execution of that test?
Right.
So
Well, that's
When we
good
can do
stuff.
things, we can do things like actually utilize that information to pull metrics and dashboards to say, you know what, we ran all these tests, right? I can look at my different test plans that I might have. I can look at what the last execution of those were, right? And these are live charts that I can actually dig into. So we have the software test plan, or even this system integration test plan that we just created. I can go right to that, and it brings me to that query back in and shows me all those execution records and what those last failures were. So.
Well, that's easy. And I can imagine that chart that you just showed us is important when people talk about, well, how done are we? Or,
Exactly.
because
where are
regardless
we at with
of,
our test?
yeah, where are we at? And sometimes it's easy to say, well, we've completed building out these requirements, but really you're not done. And in Agile, you'd call that, are we done? And that includes all the tests, integration tests, whatever they are, and are we ready to roll? So I can imagine that in one of the conversations that we had recently about ASPICE with another ASPICE expert, we talked about how the OEMs want to use ASPICE to understand how done are their suppliers in delivering a component, for example, and this could be super helpful in that regard. Well, good. Does that sort of
That kind of
wrapping
wraps
up?
up our demo today. Yeah.
Okay.
I
Well,
look
very
forward to
good.
our next conversation. This will segue good. We talked about defects. We'll talk about how we can manage problem resolutions, how we can manage change requests in the next episode.
Yeah. Well, I'll tell you what. After seeing all of this, I can only imagine that it's about as easy because you created a defect. It was easy to see everything associated with it, and I guess we'll talk a little bit more about the triage process and then how things are assigned and how you resolve things. So that'll be great. So that'll be episode 5. Look out for it, and I guess we'll wrap it up. So thanks, Amit, for joining us today.
You're welcome. Thanks, Brian. Thanks for having me.
And everybody, all our viewers, really appreciate you tuning in again to 321 Gang's Change the Conversation podcast, our technical podcast. We talk about systems and software engineering, tools, processes, and practices, and how you can improve them. So don't forget to go to the links below for more information. Please like the podcast and join our channel and all that good social media stuff that I'm probably too old to really articulate very well. All right, we'll see you next time. Thanks.